notes, you're really not going to do much note taking on this. This is more like a reference to look at because these are mostly filled in for you. But we're going to look at several vocabulary terms for circles. Okay, and these vocabulary terms for the circles, some of them you should definitely already know, and then some of them I think will be new terms that you have not really seen before. The circle is the set of points that are blank from a given point, that point being the center. Anybody have an idea of the word that goes there? I know you know what a circle is. No. It is the set of points blank from a given point. So this is telling us the definition of a circle. Okay, you're close?
The equilibrium.
Nope. It has equal in the name. It's it is equidistant. Which just means every point on the circle is the same distance from the center, right? So every equal distances is what equidistant means, right? So every point is the same distance from the outside. So like if you ever need to draw a circle, particularly in like construction or anything, if you just have a string and like something to hold that string down, all you got to do is tie whatever you're writing with, tie your pencil to the end of the string, put a nail, something, hold that end of the string down, just go around in a circle, right? It'll draw a perfect circle for you. For that, particularly helpful if you're ever like needing to draw a circle to cut out or something, like if you're building something. So, so any point on the circle, no matter where you put a point, every point is that same distance away from that center point, right? So the radius is a segment with one endpoint at the blank and the other endpoint on the circle. What word do you think goes here? No. A segment with one endpoint at the blank. Oh, Samara's got it back here. Center. So a radius, one of the endpoints of a radius is at the center. The other is somewhere over here on the circle. Right? So it's just a line from the center to the edge of the circle. Okay, that's a definition we should already, I mean, we might not be able to write down a definition, but we should be able to identify a radius already. Okay, now this one might be a new one. Have you guys heard of a chord in math class regarding circles before? Just music is probably the only place like you have really seen chord, right? Like C-H-O-R-D. There's also C-O-R-D, which would be a whole different thing too. So, so a chord is a segment with the endpoints on the circle. So the chord, it could be any 2 points on the circle being connected anywhere. Okay, so like this would be chord JK. Yes, that's first period. We got a little extra. You guys got a little extra math time. It's exciting, isn't it? All right. All right. Diameter. A diameter is a chord that passes through the center of a circle. So a diameter is a type of chord, right? Because its endpoints are on the edge of the circle, but it must also pass through the center of the circle. Okay, everybody got those there? All right, secant. Okay, now I think we're definitely probably getting into some words you probably have not ran into it before. Secant, anybody heard that one? I think this is new. So a secant is really a lot like a chord, right? A chord has its endpoints on the circle. But notice it says here, a chord is a segment, or it could have said a line segment, okay? It's a piece of a line. What has to be true about a line? It goes on forever in both ends. Like when we draw a line, it has arrows on the end, right? So a secant is a line that intersects the circle in exactly two, oh, good gracious, two places. So it's very much like a chord, like this part right here from X to Y, that is a chord. But whenever it keeps on going, it's called a secant. Okay? A tangent is a line that intersects the circle at exactly 1 point. Okay? Just 1 point. Right here. Now the word tangent you have probably seen before. It was not with circles though.
Yeah, it was
SOHCAHTOA, which was your trigonometry, like your sine, cosine, and tangent, right? So they are related there, but for a circle, a tangent line is a line that intersects the circle at exactly 1 point. So it like barely skims the circle on the outside. Tangent lines are also a key understanding in calculus whenever you look at those. But of course, we're not there yet, so we won't go into that. All right. The point of tangency is the point at which the tangent line intersects the circle. So, for example here, point Q is the point of tangency in the diagram. If you remember what a tangent is, point of tangency should be pretty easy to remember. Okay? All right, central angle. Okay? A central angle is an angle with a vertex at the center and the two sides that are radii. Radii with two eyes is just like the plural form of radius. Welcome back. Good job on your skit. We were impressed with your acting skills. We were, okay, so central angle is going to have its center at the middle of the circle. That is why we call it the central angle there. We're going to do a lot of work with these coming up. Okay, an inscribed angle. An inscribed angle is an angle with a vertex on the circle and two sides that are chords. And those of you that just came in can get the words for each one from somebody else here in a second when we get to our activity for this. So your vertex is here on one side. The other two sides are also, or other two endpoints are also on the circle, which makes these segments right here chords, because we learned a little bit ago that a chord has both of its endpoints on the circle. Okay, we all good here? All right, an arc. An arc is a portion of the blank of the circle defined by two endpoints. I guess edge. This is edge. Circle. I think there. Surely it's got to be edge because there's no. It's a short word. I don't think there's another. You could say perimeter. It's like the outside as well, but generally you don't use that. So the arc, it's not highlighted very well there, so you might want to go back over this. It's a piece of a circle. Arcs can be very useful for different things, for different design elements and things. Whether you are looking at, like, if you're building a road, whenever you're talking about curves in roads, you got to look at, like, the curvature of that road. That is an arc. It's like a piece of a circle, right? You can't have that be too sharp, especially considering, like, the speed limits. There's formulas that you would use if you were designing a road to make sure that whatever curve you have put in the road is okay for that speed limit that you have for the road. Because if your speed limit is 65 and you put a curve like this in a road, then yeah, everybody will just do like this, because they won't be able to make that turn, right? I've heard about your driving, Jose.
Oh yeah. You see him on a Friday night?
I've heard that you'd probably try it. Is that where he wrecked?
Yeah, you pick up Hector and you missed my house. Oh no, yeah, Heston. It was missed my house and then busted you and came back and go to the pasture fence and he ended up in the ditch.
Yeah.
Is that why he's working on his car? In the back of his house.
It's BMW back and better than ever.
Yeah.
I saw him working on
So be careful, please, out there. Driving is the most dangerous thing most people do every day. Be careful. Be careful. All right. Minor arcs. So there are two types of arcs that we'll talk about. There are minor arcs and major arcs. So a minor arc is an arc with a measure that is less than 180 degrees. And we only need to use two letters to name a minor arc. Okay? We will use those two letters with a little curve over top of it to show that we're talking about this piece right here. A minor arc is going to be less than half of the circle, right? So 180 degrees being half of the circle, because how many degrees are in a whole circle? 360. All right. A major arc is an arc with a measure greater than 180 degrees. We're going to need to use three letters to name this, because if we don't, it's going to look like it's just the minor arc, right? If I called this AB, then it would look like it was just the shortest distance from A to B. So if I want to name this arc, I would have to name it ACB. Or you could name it BCA. It doesn't matter whether you start with the A or the B, but the C does have to be in the middle there to let you know that you always want to start in the order that it is and go in that direction. Right there. So these are more than half of the circle. And then we can have an arc that is exactly 180 degrees, and we call that a semicircle, right? It has a special name meaning half of the circle. So it's an arc with endpoints on the circle. And it's always going to have a measure of 180 degrees because it's exactly half of the circle. You will also need to name these with three letters, because otherwise we won't know whether it's the top half of the circle or the bottom half of the circle. Okay? Some formulas that we need to make sure we know are the area of a circle. So that'll be area equals pi times the radius squared. Right? That should be one you've seen before. We also need to know circumference. What is the circumference of a circle? It's your length of the outside edge, right? And your circumference is 2 pi times the radius. Kids get these mixed up so often because they are so similar. They've got all the same numbers, right? Sometimes instead you can also, for circumference, notice that you've got like 2 times the radius. What's the same as multiplying the radius by 2? It's not going to be the same as a square in it. If I have a radius and I double it, what does it give me? The length of the diameter. So you also can use pi times diameter for that formula as well. Because if you take this 2 right here and multiply it by that r right there, that'll give you the diameter. Okay. And you will get a note card on this. So these are, I put a star next to this. These are good things to add to that note card. Okay, so this is very, very easy. Okay, and central angles to me are the ones that are the easiest to deal with. So for, oh wait, that's a laser pointer. Never used that before. That is kind of nice right there from trying to point stuff out. I need to write, so I want the pen. Okay. Central angle, we just looked at the definitions for central angle. So it's an angle with its vertex at the center of the circle, right? We've already talked about that. So the vertex of the angle has to be at the center. The sum of the central angles of a circle is how many degrees in a circle? 360. Okay, important for us to remember. The degree of the arc formed by the central angle is equal to the measure of that angle. So, for example, over here in our picture, if the measure of angle AQB, this angle right here, is 60 degrees, then the measure of arc AB is 60 degrees. So there are 2 different ways you can talk about the size of an arc. You can talk about its angle measure, and then you can talk about its arc length. Okay? So right now we're not talking about the arc length. We're talking about the degrees of the arc, how much of the circle we're looking at. So we're looking right here from A to B, we're looking at 60 degrees of the circle, 60 out of 360 if you want to kind of think about it as a fraction, what part of the circle you're looking at. It tells you nothing about how big your circle is, right? So I could have a circle like this where that arc is 60 degrees. I also could have a tiny, tiny little circle that looks about like this, and this arc would still have a measure of 60 degrees, okay? So when we're talking about the measure of an arc, we're looking for degrees. It doesn't matter how big the circle is. Does that make sense? We will look at arc length later in this unit, and for arc length, it does matter how big the circle is, and we'll talk about what to do when we get to that point. Okay? The sum of the degrees of the arcs of a circle is also equal to 360. For example, if the measure of angle AQB is 60 degrees, as we see here, it's marked, then it asks us for the measure of arc ACB. So if I am looking at this arc from A over here to C, back over here to B, so the blue arc that I have marked there, how could I find the measure of that arc? Very good. 360 minus 60 would give us 300. Okay. Questions? Everybody's got that down. Okay. All right, so we're going to do the first circle together, and we'll let you guys do the next one on your own. So the only thing they tell us about this circle is that this angle right here, JNK, is a 21 degree angle here. So, the first thing they ask us for is JK. What would we get there? Okay. All right. First thing we need is JK. It's 21. Right? So if this angle is 21, this arc is 21 degrees. Okay? Then we need the measure of JNM. So let me use a different color. Remember that whenever we're naming these angles, we got to go in order. JNM. So we're talking about this angle right here. Any ideas? 159, yes. How'd you get it? Okay. Okay. There's a little bit shorter way, but that works perfectly. So you're telling me if that's 21, that this right here has to be 21 also? You are exactly right. Does anybody remember what those angles are called? They are congruent. That's one word we could use. There's another word that starts with a V. Vertical angles. I think I heard somebody say it there. You said, who said vertical? Was that Abby? That was Emma back there. Vertical angles. Vertical angles, those ones across from each other right here, those are going to be congruent. So if that's 21 and that's 21, Carson's saying you took 360 and you subtracted like 42, right? Because 21 plus 21 gives you 42. And then that gives you 318. And then what'd you do after that? Okay? And then 318 divided by 2 is going to give you 159, which is correct for this angle right here. Because this angle has to be 159. Also means this angle over here is going to be 159 because those are vertical angles as well. Right? And we could double check ourselves by adding all of these together to make sure we get 360. Does anybody know a different way we could get 159? Okay, what, Jalissa? Okay, because right here, this is half the circle, right? So if we just do half of the circle is going to be 180, and we could just subtract the 21, and we could also do 180 minus 21. That would give us 159. So that's another option for how you could look at it, right? But both of them will get you the right answer. Now that we've got all those angles, the rest of these things should be pretty simple to come up with. So the next part asks us for arc KL here. So Joey, what would we get for KL? 159. Very good. And then, let's see, it asks us for arc JKM. JKM, I've got to go around this direction. Okay, what do we do here, Fernando? That'll work. I like that. 21 plus 180, because you're shortcutting this a little bit. You could do 21 plus 159 plus 21, but we know 159 plus 21 is 180 because it's half the circle, right? So 21 plus 180 is going to give us 201. There. Does that make sense? You could also do 21 plus 159 plus 21, also give you the same amount. There. And then our last one, and I'm running out of color, so it's going to start overlapping here. I'm going to use red again. MKL, so from M to K back to L. So we're going almost all the way around. What do you think, Samara? Okay, that's the quickest way to get there. 360 minus 21 is going to give you 339. Is that right? Yeah. 339. That's the quickest way because we know the whole circle is 360 and we're just not using that 21 degrees right there. All right. So that gets us all of our arcs and angles here. Okay. Try the next one on your own.
This is what
Um,
this more she wants to see it because
yeah.
the schedule right now has teacher days.
Yeah, because they won't be here, right? And so we would have Friday and then.
So right now the math 3 is on Wednesday. Math 3 is on Wednesday.
Right.
You should, I think we should just leave it how we have it.
Yeah, because I don't know why we need to do it on Friday.
I mean, someone that's how we I'm gonna say that we would do like that.
Yeah, I would prefer to just leave it like that. Yeah, because we need every moment we can get. They've done been asking for a free day today. That's something never. Good. All right. Check with your neighbors whenever you get your answers. See if it. Caden, you coming over here to help Hector out or just give him a hug of encouragement? All right, you got 30 more seconds. Check what you got. See me after class. Okay. Return to your seats. Let's see what we got. Might need to have my calculator ready because I don't have this. Okay. All right. We got UXV. So UXV right here. Okay. UXV. Cannon, what'd you get? UXV, that first one, the angle. 72 is correct. Because if this angle is 72, or this arc is 72, this angle is 72, which makes this angle also 72. Vertical angles there. Very good. All right. Emma, what'd you get for ST? Arc ST. 21 is correct. How do we get that? Right here, because WU is a diameter and cuts that circle in half, right? So these three arcs right here should add up to 180. So that works beautifully there. All right, then we had to find WV. So WV is all the way from here to here. All right, Zoe, what'd you get? 108 is correct. What'd you do?
180 minus 72.
Very good. Because WU cuts that circle in half. So you should have 180 degrees right here. And if you do 180 minus the other angle, which is 72, you will get 108 there. Then we have TW. So from T to W, since it only has two letters, you're going the shortest distance. So we're talking about this arc right here. Hunter, what'd you get for TW? Let me mark what we got here. This is 21. I didn't mark that. What would we get? Okay, 93. Very good. And all we have to do for that is 72 plus 21. Okay. The very last one, I'm going to go back to red, is TVW. TVW. So all the way around the circle this direction. Let's see. Caden, what would we get for that one? Let me make sure, because the numbers are getting larger on that one. 267 is correct there. What did you do to get that, Caden? $360 minus that 93 we just found, right? Because the 93 was that black part. Arc TVW is the rest of the circle, so that'd be the quickest way to find it. That's very good. Okay, questions? Okay, these take a little thinking, like piecing things together, but I like them because, like, once you do see what's going on, they're pretty quick to do. All right, let's look at one that makes us do a little algebra. Some of you love it, some of you hate it whenever they make us do algebra. But for this, we will need to set up an equation for this. So we might need to know that two things are equal. We might need to know that they add to 180 or they add to 360 or something of that nature. So in the first problem there. Heston, I've got 9x plus 15 here. I've got an angle of 66 here, which also would mean that like I've got arc of 66, which also means my angle is 66 right there. What do you think we could do on that one? Good. If I add those two together, it should equal 180. So I would say 9x plus 15 plus 66 is going to equal 180. And then I've got a equation to solve. It's a pretty simple equation. Do remember, if your equation solving skills are horrid, you could always type this into Desmos, right? F of x equals the left side, g of x equals the right side. But let's solve it by hand because we're better than stooping to Desmos on this. So we're going to have 9x plus, that's going to be 81 if we add those two together right there, equals 180. Let's see. Jemija, what do I do to finish solving that? Good. We'll subtract that 81. That's going to give me 9x equals 99. And last step, Jemija, divide by 9. So the x will equal 11. Okay? 4 is a little different. Look at that one. Anybody have any ideas on number 4?
9x plus 10 plus 43 is equal to 134.
Perfect. 9x plus 10 plus 43 is going to equal 134 degrees. Because if I draw out, like if I'm focusing on these two lines right here, then this angle and this whole angle would be, they'd be vertical angles, so they're equal to each other, right? So if this is 9x plus 10 here, and this is 43, then I can just set those two pieces equal to each other. So that is going to be 9x plus 53 equals 134. Like that. How do I finish solving that one, Heston? Alright, so 134 minus 53 is going to give you 81. And then you'll divide. What are you going to get for your final answer on that? 81 divided by 9? 9. Very good. And again, remember, if you are not great at solving equations, if you mess them up every time, then you always have the option. We're not going to drag the computers out for the last 5 seconds of the class, or 9 minutes of the class here. But you always have the option of just doing this, where, like for that first one, you just do f of x equals 9x plus 15 plus 66. G of x equals 180. You'll have to zoom way out. But if you do, they will cross right there at x equals 11. All right, so you always got a Desmos backup if it starts getting more complicated than you're able to handle. Although, I think we can handle it. Okay, let's talk about an inscribed angle real quick. Okay, inscribed angle is an angle with its vertex on the circle with two sides that are inside the circle. The intercepted arc is going to be the arc that lies between the endpoints of an inscribed angle. So, for example, here, in this picture, angle ABC, this angle ABC, this angle right here, that is your inscribed angle for this. And then the intercepted arc for that angle, it's only specifically for that angle, That intercepted arc is AC. So this would be your intercepted arc for, that's supposed to say 4, that's R, for angle ABC. Okay, and so these are different than your central angles. Central angles are going to be your easier ones because central angles just equal the measure of the arc, right? It's just equal. The degree of the inscribed angle is half the measure of its intercepted arc. Okay, everybody good there? All right, so we got some pretty quick examples right here. If I know this angle right here is 57, what would I do to find arc ZY, which is where I've got the, nope. This is an inscribed angle right here. It is going to be half of its intercepted arc. So if this is 57, the arc is going to be 57 times 2, which is going to give you 114 degrees. The arc is always going to be bigger than the inscribed angle. So 6 looks a little more complicated, but it's asking us for the measure of arc from Q to S. If they only use 2 letters, it's the shortest distance. So we're talking about this here. Now, here you don't have any central angles. You only have an inscribed angle. And that inscribed angle for this one would be angle SFQ. So, Jose, what would I do on this one to find the measure of arc QS? Nope. It's really the same as this last picture. It's just got these other lines, but they really don't affect what's happening, right? Imagine that these 2 lines right here are not even there at all. All you have to do is take your inscribed angle and double it. So 79 times 2, let's see, 80 times 2 would be 160, so that's going to be 158. There. Okay, let's see if we can get these next couple done, and then we'll be done for the day. All right, so now 7's a little trickier because it asks for arc JK, but the angle that we have is 45 degrees right here. So if this angle right here is 45 degrees, then the intercepted arc that goes with it is KL. Okay? Richard, what would I do to find KL? Not divide. The angle is always smaller than arc. We just multiply by 2. This would be 90. Okay, what? KJ is also going to be 90 because they have to add up to 180. It's half of the circle, right? So we would get arc KJ would equal 90 degrees. Okay, we're going to have a similar problem over here. We've got KLF. We know this angle. Well, then we can find the arc that goes with it. That's this arc here. It's not the arc you're asking being asked for, but you need to find it first. So, Cannon, what would we do to find arc KF here? We just did it over here. Here was 45. We got 90. This is 52. Multiply by 2. We'll get 104. Okay? But they didn't ask us for that one. They asked us for FM. Not divided by 2. 76 is good. We do 180 minus 104, which will give me 76. Okay? It is 150, 1050 when we got. Yes. So we're going to go ahead and stop for today. We'll finish these up on Monday and do some practice with it. Okay?